All right, so for the worksheet 37 on volume, 4C. All right, shh. First intersection of y equals sine x and y equals cosine x when x is greater than 0, and then x equals 0. So job 1 is to sketch the area. Well, I know what sine looks like. I know what cosine looks like. And so their first intersection is right there. Of course, now I got to figure out where that is. And you might know it graphically. You might know it like algebraically, set them equal to each other. So sine and cosine, they equal each other at pi over 4. And I mean, there's kind of a hint there because the scale goes to 0.25 pi. So that's pi over 4. So the sine curve starts at 0 and goes up to root 2 over 2, which is like 0.7 or so. So there's the sine curve. Cosine starts at 1 and goes down. So there's the cosine curve. So there's our starting area. And we want to rotate that around the y-axis. So let's mirror it across. Like that. So this is a disk problem the whole way. There's no washers in there. Are we slicing dx or dy? Dy. And so there's no little r. There's only big R, but something is kind of odd about this problem. Like, what's big R equal to? Okay, good. What's x equal to? Yeah.
Y over cosine.
So this down here is y equals sine of x. So how do we how do we get x by itself? But you can't divide by sine because sine is you're doing something. That'd be like saying divide by a square root. Like, well, can't really do that. How do I undo a sine? Inverse sine. So x equals inverse sine of y. So that's going to be weird, but hey, the calculator's doing it, so we can handle that. So that's big R, except that, you may see what the problem is here? There's two big R's, because I guess we can call that R1. And then up here it switches. R2 is something else. It's still an x value, but that one is inverse cosine of y. So I'm going to need two integrals from 0 to there. What's there? What's the y value? So the x value where they were equal was pi over 4, but what's the y value there? What's the sine of pi over 4 and the cosine of pi over 4? You're close. Root 2 over 2, which is 0.7 something or other. So I'm going to integrate from 0 to root 2 over 2 of inverse sine of y squared dy. So that'll get the bottom cone looking piece. That would be that piece. And then you get the top piece from root 2 over 2 to 1. Inverse cosine of y squared dy. So yeah, that was a weird one because it took two different integrals because there were two different r's because there's like two different volumes stacked on top of each other. So that's a really good question because there was some weird stuff going on in that, plus all the trig that was happening. Good one. Other questions? None? Okay.